Hello, everyone. My name is Renuka Sindhgatta from Queensland University of Technology, and this is joint work with Arthur Hofstede from QUT and Aditya Ghose from University of Wollongong. And in this work, we present a design approach for an adaptive robotic process automation by specifying different types of resources and their characteristics. So I'll get started with a brief introduction on robotic process automation. Robotic process automation, or RPA, is one of the recent business process automation paradigms. And here, software programs or bots mimic humans and perform different tasks of a business process. And these bots are suitable for repetitive and structured or close-ended tasks. So on the right side, we have an example of a human operator, a data entry operator, taking information from different systems like a customer information management system, a credit limit verification system, a tax valuation system, to create a new credit account for a customer in a bank system. Now, these are close-ended tasks, and they could be done by a software system or a software program or a robot. So till recently, the robots that have been used commonly automate information acquisition tasks like collation of data, screen scraping, reading a structured document, and so on. But recent advances in AI-enabled techniques such as machine learning and their application to various domains has allowed automation of decision-making tasks as well, like insurance claim approval, credit scoring, or loan approval. And so this has extended the automation capabilities of using software robots. So I'll give a brief example of a IT incident management process. This is simplified for illustration. So here what would happen is a customer could call a help desk agent, and the help desk agent would consider all the details and create an IT incident. The help desk agent would then assign the incident to a team and a service agent. The service agent would look at the incident and understand, analyze the root cause, and then resolve the incident. And finally, the service agent would update the details in the incident and send a mail to the customer saying that the incident has been resolved. Now, if this process would need to be automated, one way to look at it would be the receiving of calls from a customer and creating an IT incident can be done by a chatbot. The assigning of team and a service agent could be done by a machine learning model or a classifier. And then identifying the root cause and resolving the incident might be a fairly complex task, so it could still be done by a human agent. But updating incidents and sending mail to the customer is a close-ended task, so it could be done by a robotic agent or a software program. So what we see here is there are different types of tasks which can be automated by different types of agents, and there's interaction between these agents and the human agent. So we could categorize broadly 3 types of resources in executing a business process. A human agent who is capable of executing all types of tasks in a business process. Intelligent agents, these are software algorithms that can learn from historical data and execute the tasks. In the context of this work, we limit IA to statistical machine learning models that learn from the data, but this can be easily generalized to any software algorithm that can learn from data. And finally, we have the robotic agents, which are software programs that could either do close-ended, structured information acquisition or information gathering tasks. Now, given these resources, they would have specific characteristics, much like human agents. So resource characteristics have also been referred to as criteria, resource profile, or resource ability. They have largely been studied in the context of human agents, but here we're looking at it for all types of agents, the HA, IA, and an RA. And we could see that there are certain resource characteristics that are significant for human agents, but may not be that significant for a robotic agent or an intelligent agent. So, for example, preference and collaboration may not be that important for an IA and an RA. Similarly, availability, workload, and duration again may not be important or significant for IA or RA, given that they would always be available and they can handle significantly large amount of workload. So we'll just go through some of the resource characteristics considering an intelligent agent. So performance or quality of an intelligent agent can be different for the same task with different task attributes. So here's an example of a machine learning model that can take an incident description and identify the team that incident needs to be assigned to. So this ML model can be trained using historical data of all the past incidents and the teams it has been resolved by. So here you would see that we could measure the performance of classifier, the various metrics, and we look at the confusion metrics of the classifier. So the rows depict the actual class, the actual team that resolved the incident. The columns depict the team that was predicted by the classifier. So the diagonal elements would indicate that the right predictions that have been made by the classifier, while the off-diagonal elements indicate the confusion that's there in the classifier. So we could see that team A and team C are having higher accuracy, whereas the classifier has poor performance when predicting team B. There could be other resource characteristics as well that could vary with task attributes, like suitability. So there might be certain business requirements that may mandate the need for an HA doing a particular task, in which case the IA and RA may not be suitable for doing that task. For example, a loan approval may require an HA to approve loans greater than a specific amount. Similarly, you might have experience where the resource gains the experience by doing more number of tasks. So recently or a newly deployed intelligent agent would have poor performance, a poor experience on certain tasks. Now, given these tasks, resources, and their characteristics, you could achieve different levels of automation. So it may happen that the automation would not be a completely manual or full automation, but it could be at various levels. So there are various scales of automation that have been studied in human automation studies, and they vary from 3 levels of automation to 11 levels of automation. But largely they can be categorized into these 4 levels. So at manual level, the automation agent can offer no assistance, so it has to be done by a human agent. A decision support would be where an automation agent performs the task, but it's more like giving some support to a human agent who ultimately does the task. A supervisory control would be, on the other hand, where the automation agent does the task and human agent can intervene if required. And finally, full automation is a scenario where the automation agent carries the entire or performs the entire task. Now, the characteristics of the resources can determine the levels of automation. And what we present here are declarative constraints that would enable these process adaptations to support levels of automation. So here we are illustrating intelligent agent or a human agent executing the task A. So at a manual level, the human agent would perform the task A and the intelligent agent would not be doing that task. And subsequently, a task B is done by a robotic agent. In a decision support scenario, an intelligent agent would execute the task A, it would be followed by a human agent doing the same task A with inputs from the intelligent agent. And finally, the task B is performed by a robotic agent. In supervisory control, the intelligent agent performs a task A, and here we could have a scenario where, in certain cases, a human agent may perform a task A prime, which is similar to task A, like it could be verification of what the intelligent agent has done, or redoing that task, and so on. And subsequently, in both these cases, the task B would be performed by a robotic agent. And finally, in full automation scenario, the task is performed by an IA and it is not performed by an HA. So these are the 4 levels of automation that we could configure using these declarative constraints. So here we would illustrate our approach using a BPIC 2014 event log, which relates to a service interaction and incident management business process. So we simulate an IA, we compute the resource characteristics of the IA, and then configure different levels of automation. So the IA we are simulating is the agent that would identify the team that a incident should be assigned to by considering the urgency, the priority, the type and subtype of the configuration item. And the IA here is a machine learning classifier which identifies the team. So we built the intelligent agent by looking at the 13,000 incidents that have been resolved by a single team over a period of 6 months. And the entire data is split temporally. The first 80% of the data is used to train the classifier and test its performance or evaluate the performance. The remaining 20% of the data is considered unseen data to configure different levels of automation. For the classifier, we use a random forest classifier, but we could have used any classification algorithm. The objective is to see how we measure the performance or the resource characteristics and configure levels of automation. So the random forest classifier considers the 4 features which are available in the event log: the urgency, priority, the configuration item type, and the CAiSE subtype as input features. And the output prediction is a team that resolves the incident. So once we build the IA, we can use the confusion matrix to evaluate its performance. So the overall accuracy of the intelligent agent is 72.6%. But if you look at the confusion matrix, we could see that there are certain scenarios where the IA is very good at predicting the teams. For example, team 0015. Versus it has a very poor performance when predicting team 0031. It's almost 0% accuracy. So given these varying performance for different types of task attributes, we could now configure the levels of automation. So one way of doing it is you define thresholds on the performance and experience of the IA required for different levels of automation. So if the task performance, if the performance of the IA on the task is very low, like when predicting team 0031, then it needs to be done manually by a HA. So, and then we see that the IA has suitable performance, but then there's low experience, then it could be used for decision support where the IA does the prediction, but it's followed by a human agent doing the same task again. If the performance and experience of the IA is suitable, then it could be a supervisory control where the HA could verify if the team assignment is valid or not. And finally, when the performance and experience of the IA is high, then the task could be configured to full automation, which means there's no human agent involved. So given these levels of automation that can be achieved, by setting different thresholds on performance and experience, like the tau performance minimum, tau experience minimum. We can compute the levels of automation that can be achieved for the 20% of the unseen data. So what we do here is we compute the performance of the classifier based on the teams it has predicted, and we take an average for every day. We compute the experience of the IA, and this you would see a gradual increase in the experience as IA is predicting more and more teams. And then by defining these thresholds, different levels of automation can be achieved. So on the right side, you would see that on day one, most of the tasks are either done manually by an HA or they are used for decision support. But as we go, for example, on day 34, we would see some fully automated tasks as well done by the IA. So here's how, with over a period of time, different levels of automation can be achieved. In the paper, we've also shown illustrated with another example of a chatbot. But essentially, we present the same approach of evaluating the performance of the intelligent agent and then configuring different levels of automation. So to conclude, in this work, we consider different types of resources and their interactions with human agents. We present a declarative constraint specification that could achieve different levels of automation based on resource characteristics. And this work presents a starting point for supporting more advanced forms of automation and interaction between resources. Now, these resource characteristics and their values suitable to achieve different levels of automation can be configured. And this leads to a trade-off between the level of automation that you can achieve and the overall cost and performance of process execution. If we set the threshold very high, it would lead to a completely manual automation, whereas very low would probably result in low accuracy. So the choice of these resource characteristics and the values for achieving different levels of automation is a possible avenue for future work that we would like to explore. So that's all I had, so we could open up for questions. Thank you very much.